Hello everyone, this is Chinnaiah Kalpana here. In this video, we are going to solve a differential equation from higher order linear differential equation. So let's get going. Problem. Solve d square plus 3d plus 2 into y equals to e power 2x plus sine 2x. Solution. Given differential equation. D square plus 3d plus 2 into y equals to e power 2x plus sine 2x. Firstly, let's find the order and degree of the given equation. Can write the equation as we know that d differential operator equals to d by dx. Then you can write the LHS part of equation as d. Firstly, let's multiply all these three terms with y, then you'll get d square y plus 3dy plus 2y equals to e power 2x plus sine 2x. Right? Now, we know that d square equals to d square by dx square. Then you can write d square y as d square y by dx square plus 3 into dy by dx plus 2y equals to e power 2x plus sine 2x, right? So let's identify the highest derivative here. D square y by dx square is the highest derivative, so the order of the equation is 2 and highest power of the highest derivative is the degree. So here our degree is 1. By looking at the equation itself, we can say that the degree is 1 and order is 2, right? Order is 2 and degree is 1. Right now, we are given a differential equation which is in operator form. F of d into y equals to q, right? We are given equation in operator form. The equation is in f of d into y equals to q form, right? Where f of d equals to d square plus 3d plus 2 and q equals to e power 2x plus sine 2x. So we are given a q which is in e power ax form and also sine ax or sine bx form, right? One is in e power ax form and one is in sine ax or bx form, right? Now, we need to find the general solution to the given non-homogeneous differential equation using y equals to yc plus yp. Here yc is complementary function which is obtained using roots of the auxiliary equation of homogeneous equation of the given non-homogeneous equation. Simply if you take RHS to 0, you'll get the homogeneous equation of this non-homogeneous equation and you'll find yp using 1 by f of d into q. Now let's find complementary function using the auxiliary equation. The auxiliary equation of f of d into y equals to 0 is f of m equals to 0, where f of m equals to, you're having f of d equals to d square plus 3d plus 2, right? Let's replace the differential operator by m, then you'll get f of m equals to m square plus 3m plus 2. Then our auxiliary equation becomes m square plus 3m plus 2 equals to 0. Now we can find the roots. Let's split 3m as 2m plus m plus 2 equals to 0. Now take m common from the first two terms, you'll get m into m plus 2 and write the next two terms as it is. you notice you're having m plus 2 in both the terms. So let's take m plus 2 common. Then you get m plus 2 into m plus 1 equals to 0. If you equate each factor to 0, you'll get the roots. If you equate first factor to 0, you'll get m equals to minus 2. If you equate second factor to 0, you get m equals to minus 1. Then m equals to minus 2 and minus 1 are the roots which are real and distinct. Therefore, m equals to minus 2 minus 1 are the roots of the auxiliary equation which are real and distinct. Right? Now we can write the complementary function using these roots. Complementary function. We know that if two roots are real and distinct, then the solution or the complementary function is given by y is equals to c1 into e power 1 root into x plus c2 into e power another root into x, right? If these two roots are real and distinct, then our complementary function will be c1 into e power 1 root. You can take any of these two, minus 2 into x plus c2 into e power another root into x. Then y is equals to c1 e power minus 2x plus c2 e power minus x, right? Therefore, y is equals to c1 e power minus 2x plus c2 e power minus x, or you can just write it as y is equals to, in the place of minus 2, write minus 1, minus 2 here. Then you will get c1 e power minus x plus c2 e power minus 2x. Okay. I'll take this. Now let's find yp. Particular integral. We know that particular integral is given by yp equals to 1 by f of d into q. We have f of d equals to 1 by d square plus 3d plus 2 into q e power 2x plus sine 2x. Right? We can just split this as 1 by f of d into e power 2x plus 1 by d square plus 3d plus 2 into sine 2x. We can find each fraction or each term separately. We are having yp equals to 1 by d square plus 3d plus 2 into e power 2x plus 1 by d square plus 3d plus 2 into sine 2x. Right? The first term is of the form 1 by f of d into e power ax, and second term is of the form 1 by f of d into sine ax, or 1 by f of d into sine bx, whatever it is. Okay. So here for a equals to 2 you have this one, and here you have for a equals to 2. Right? So firstly, let's find the first one. Let's name it as yp1 and second one as yp2. yp1 equals to 1 by f of d into e power 2x. Right? You're having f of d equals to d square plus 3d plus 2. Now let's find f of 2, you'll get 2 square plus 3 into 2 plus 2, which is equals to 4 plus 3 2s are 6 plus 1, no, plus 2, which is 12, not equals to 0. Since f of 2 is not equals to 0, so what we can do? We can just replace d, right? D by 2, then you get we already know that f of 2 is non-zero, so we dare to replace d by 2, okay? Or we can just write 1 by some f of 2 into e power 2x. Both results to a same result. 1 by 4 plus 3 2s are 6 plus 2 into e power 2x, which is equals to 1 by 4 plus 6 10, 10 plus 2 12 into e power 2x, and here it results to, right? So we got the same result. Therefore, here you need to write, since f of 2 equals to 12, right? Therefore, yp 1 equals to 1 by 12 into e power 2x, or e power 2x by 12. Now let's find yp2. Now let's see what happens if we replace d square by minus a square, right? For a equals to 2, you'll get minus 2 square equals to minus 4, and the denominator becomes minus 4. Simply replace d square by minus 4 and see what you'll get. Equals to minus 4 plus 2 is minus 2 plus 3d. You can just write this as 3d minus 2, which is not equals to 0, right? The denominator won't get 0, or the denominator will not become 0. If you get 1 by 0, the total fraction becomes undefined. So we'll check it by replacing d square equals to minus a square. Okay, since the denominator is not equals to 0, so we can just replace d square by minus a square, which is equals to minus 4, right? Then you'll get 1 by, replace d square by minus 4. Already we have checked here, right? You can just write the same steps, or you can do it again. Equals to 1 by minus 4 plus 2 is minus 2 plus 3d into sine 2x, which is equals to 1 by 3d minus 2 into sine 2x, right? Now what we have to do? Here in the denominator you are having 3d minus 2, right? We'll multiply and divide with 3d plus 2 into sine 2x. Okay? Or what happens if you get this? Okay? You'll just take minus common, then you'll get 2 minus 3d, right? Then into some sine 2x, let it be. Then you can just write it as 1 by minus 1, right? You can just split it as 1 by minus 1 into 1 by 2 minus 3d, right? Into, here you're having 2 minus 3d, so let's multiply and divide with 2 plus 3d. Then you will get minus of 1 minus 1 by 2 minus 3d minus 1 by 2 minus 3d into, you can write a plus b as b plus a also. Then you'll get 3 plus 2 into, divided by 3 plus 2, right? Into sine 2x. Now, here also you can take minus common. Then what you'll get if you take minus common from 2 minus 3d? You'll get, you can just write it as, right? Now take minus common. You'll get minus of 3d minus 2, right? I'll replace 2 minus 3d by minus of 3d minus 2, right? You'll get minus into 1 by minus 3d minus 2, which is plus 3d minus 2. Again, you'll get the same thing. Okay? Either you can change this, that is take just minus 2 common, or you can write positive term plus and negative term, that is the term involving negative sign, and do like this. Okay? You'll get the same answer. Now, we can write this as d 3d plus 2 by 3d minus 2 into 3d plus 2 into sine 2x, right? Which is equals to 3d plus 2y. We can just write it as 3d plus 2 into 3d minus 2 into sine 2x. The denominator is in a plus b into a minus b form, which is a square minus b square, right? Then you'll get 3d plus 2 by 3d whole square is 9d square. Since 3 square is 9 and d square, right? Minus 2 square is 4 into sine 2x. See, in the denominator you are having d square again. So let's check what happens if we replace d square by minus 4 in the denominator. Okay? Before putting into the solution, we always check here whether we are getting a non-zero term or zero term. We have to check. Consider the denominator and replace d square by minus 4 and see what you'll get. 9 4 is 36, that is minus 36 minus 4, which is equals to minus 40, right? Which is not equals to 0. So what we can do now? We can just replace d square by minus 4 since the denominator will not become 0, right? Then this becomes 3d. Okay, replace d square by minus 4, then you'll get 3d plus 2 by 9 into, I'll just write the same steps here, minus 4 into sine 2x, which is equals to 3d plus 2 by 9 minus 4 is minus 36 minus 4 into sine 2x, which is equals to 3d plus 2 by minus 40 into sine 2x, right? You can split this as 1 by minus 40 into 3d plus 2 into sine 2x, right? You can write 1 by minus 40 as minus 1 by 40 into 3d sine 2x, that is derivative of 3 into derivative of sine 2x plus 2 sine 2x. Is equals to minus 1 by 40 into 3 into derivative of sine 2x is 2 cos 2x plus 2 sine 2x, which is equals to minus 1 by 40 into 3 2s are 6 cos 2x plus 2 sine 2x. You can take 2 common from these two terms if you want. Now we are having yp2 equals to minus 1 by 40 into 6 cos 2x plus 2 sin 2x, right? You can split this as minus 1 by 40 into, now take 2 common from these two terms, you'll get 2 times 2 3s are 6, right? 3 cos 2x plus sin 2x. Now this equals to minus 1 into, take this 1 by 40 inside the brackets, you'll get 2 times 3 cos 2x inside the square brackets, okay? Sin 2x by 40. 2 ones are 2 20s are. This is equals to minus of 3 cos 2x plus sin 2x by 20, right? Therefore, yp2 equals to minus of 3 cos 2x plus sin 2x by 20. Now coming to yp again. We got the results of yp1 and yp2, right? So let's replace it. So the result obtained from the yp1 is e power 2x by 12 plus result obtained from the second term is minus of 3 cos 2x plus sin 2x by 20. Then yp equals to e power 2x by 12 plus into minus minus 3 cos 2x plus sin 2x by 20. Now we can write the general solution. The general solution is given by y equals to yc plus yp. We have yc, complementary function is c1 e power minus 2x plus c2 e power minus x plus yp plus e power 2x by 12 minus of 3 cos 2x plus sin 2x by 12, right? Therefore, y equals to c1 e power minus 2x plus c2 e power minus x plus e power 2x by 12 minus of 3 cos 2x plus sin 2x by 12. So we have seen a problem from higher order linear differential equation in this video. Hope you'll understand. We'll see you in the next video. Until then, bye bye.